Good morning, students. Last video we have studied about altitudes. What are altitudes? Altitudes is a line drawn or a perpendicular drawn from the opposite vertex to the side is known as altitude. Okay. Uh, Now altitude is perpendicular to the base. Fine. These altitudes meet at one point, intersect each other at one point. That point is known as point of concurrence. For every Cevian. Now, what are Cevians? Cevians are altitude, median, angle bisector, perpendicular bisector. Okay. Now, wherever these meet, that point is known as point of concurrence. Now, for every Cevian, the point of concurrence is named differently. Okay. For altitude, it is named as orthocenter and it is represented by letter O. Okay. For obtuse angle triangle, altitude lies outside the triangle. For acute angle triangle, it lies inside the triangle. And for right angle triangle, it lies on the vertex where the perpendicular is drawn. Okay, where the two sides are perpendicular to each other. Now we come on to the next topic, that is median. Now what is median? Median is a line drawn from the opposite vertex to the base such that it divides the base into two equal parts. Now here we see the figure, in figure AP is drawn, okay, and it is dividing BC into two equal parts such that BP is equal to PC. The length of BP will be equal to length of PC and P is the midpoint. Okay, so here AP is known as median. Median, the segment joining the vertex and midpoint of the opposite side, is called the median of triangle. Okay, in triangle ABC, I've said you AP is the median. Now, median are concurrent. Now, what do you understand by the word concurrent? They intersect at one single point. And their point of contact, that is point of concurrence, is called as centroid. It is represented by letter G. By drawing the perpendicular bisector of segment AB. Now, I don't know what is the length of AB. So, first we will draw the perpendicular bisector and then we are going to measure the length of AB and the two sections of the segment AB. Now to draw the perpendicular bisector, what I have to do? I have to take more than half of it. So by mere observation, you can take more than half of it. So here, by mere observation, you can take more than half of it. Okay. To draw median, what you have to do is you have to draw the perpendicular bisector of the side, okay, of the opposite side. The perpendicular bisectors are used to draw the median. So very first thing that we are going to do is we are going to find out the perpendicular bisector of segment AB. Now we don't know what is the length of AB, okay. I have just drawn it. And first we will draw the perpendicular bisector, then we are going to measure the length of AB and the two sections divided by the perpendicular bisector. Okay, now to draw the perpendicular bisector, what I have to do? I have to take more than half of this particular line segment AB. So by observation you can see that it is more than half. Here I am marking. Is it more than half? Yes. So what I'll be doing, I'll be drawing an arc above it and below the line segment AB. Okay, by keeping the pointer on B. Then I'll be keeping the pointer of the compass on A and then intersecting the previous arc which was drawn by keeping the compass at point B. Okay, so I'll get the two point of intersection. What I'm going to do with it, I'll be joining that. Okay, so here I join it. Right? So this is what? This is perpendicular bisector. Now let us measure what is the length of AB. Length of AB is 6.4. Okay. Length of AB. How much it is? 6.4 centimeter. Okay. And what is length of, I'll name this as O. So what is length of AO now? Length of AO is 3.2 centimeter. Length of AO equal to 3.2 centimeter, and similarly length of OB is also 3.2 centimeter. From this, what do you observe? That length of AO is equal to length of OB. Means what this line is doing? This line is dividing AB into two equal parts. So this concept we are going to use to draw the median. As such, perpendicular bisector, only the midpoint we get. For that purpose we are drawing it. Okay. Now first we will see how to draw the median of a triangle. For that we will draw a triangle first. So here, triangle. I have drawn. Okay, I'll name it as PQR. Okay. Now to draw the median, what I have to draw first? I have to draw the perpendicular bisector of the side. Okay. Now to draw the perpendicular bisector, what I have to do? I have to take more than half of QR. For QR, we are drawing the perpendicular bisector. Okay. So I'll be taking more than half of it by simple, what you can say, by simple observation you can see that it is more than half of QR, right? So what I'll be doing, I'll be drawing arc on both the sides, drawn. Then same way I'll be drawing arc over here and below line QR. Okay. Now the previous arc was not intersecting, so I'll just increase the length of the arc. Now two arcs are intersecting. Now see, I'll be drawing the line over here so that the 2 points of the arc, intersecting arcs, I join with the help of a line. Now this is perpendicular bisector. Now what I have to do? I have to draw the median. So what I'll be doing? I'll be joining this point and vertex. Okay, with the help of the dotted line over here. Right. Now this PA is the median. So for all three sides we have to draw in the same way. Now we will be drawing the different types of triangles and observe where do the median lie. We will be drawing the median for acute angle triangle, that is triangle PQR. Same way we have to draw for each side. We have to draw first perpendicular bisector. For perpendicular bisector I have to take more than half of each side. So first QR I'll be taking. I have drawn triangle PQR, and for QR I am drawing the perpendicular bisector. So here I have taken one of the arc, and on the other side, means below point R I am taking an arc. Okay. Then from Q also what I'll be doing? I'll be drawing the arc. Now you'll see it's coming inside, no probs. I'll be increasing the length. Okay, this way. So I'll be drawing a line now. So to draw the line, I'll be using pencil. Okay. So somewhat this way you're going to get. Now this is the point of contact. Name it as H. Okay. I'll be joining P and H now. So PH is the median for the triangle PQR on side QR. Okay. Now I'll be drawing for PR. Right? Did I get the point of intersection from point R? Yes, it is there. Here I have to extend a bit. Now I'll be drawing a line. Now this is the side, that is PR, where I got the point. I'll name it as S. Fine. And I'll be joining QS, and opposite side, opposite vertex is Q. So QS is to be joined, and QS will be the median for triangle PQR at point on the side PR at point S. Okay. Now the last side is left, that is side QP. So for QP, again I'll be taking a bit maybe coming inside the triangle, so that's why I've extended a bit. Okay. See, I told you, no, it's coming inside the triangle. Fine. So I'll be joining this. Now perpendicular bisectors may meet the vertex, may not meet the vertex. So don't worry about it, okay? We are not interested of, we are just interested in getting the midpoint with the help of the perpendicular bisector. Okay. Now here PQ, I'll name it as M. Right. So SHM are the midpoints of the respective sides. Now what I'll be doing with this point I'll be joining over here. Fine. So this is the point that I'm getting. So that is point G, centroid of the median of acute angle triangle. Now here also the centroid is lying inside the triangle. In obtuse angle triangle also the centroid was lying inside the triangle. In acute also it is lying inside the triangle. Okay. Now we'll move on to the right angle triangle. So here is the right angle triangle. I'll be drawing it is more than half, right? So here it is this way. You have to draw the arcs. You all are aware of it now, right? Joining the arcs with the help of the line, points on the arcs with the help of the line, right? Now here, this is the point that I'm getting. What I'll be doing, I'll be joining with the help of a pen. Why I'm using pen over here? Because too many lines are there. We will be confused which is the centroid and which is the perpendicular bisector. So the pen dotted one are the centroids. Okay. So X for YZ I have taken the midpoint. Now I'll be taking XY. Okay. So this way. Now xy is the side, opposite vertex is z. So I'll name this as Q. Okay. And this Q and Z will be joined. Right? So ZQ is the median for triangle XYZ at on side YX. Okay. Now last side that is left is ZX. So ZX more than half. So here it is more than half. I'll be joining this now. 2 points on the arc. Right? So here this is done. Now what I have to do? I have to just join the point. This is Q. I'll name it as R. So this R will be joined with Y because Y is the opposite vertex for XZ. Okay, little it is shifted. Okay, so this is point G over here. Right? So in right angle triangle also the vertex, the centroid is lying inside the triangle. So from this what do we conclude? We conclude that for all the triangles, the centroid lies inside the triangle. Okay, this we conclude. Fine. Now there is one of the activity that we have to perform. Okay, now what is